Welcome to the chapter Matter Around Us.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Explain the states of matter. Identify the shape and volume of solids, liquids and gases. List out the characteristics and properties of three states of matter. Discuss the diffusion of states of matter. Explain the force of attraction between the particles of the matter. Describe the effects of temperature of matter on changes of state.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In lower classes, we studied about metals and non-metals, synthetic and natural materials, acids and bases, etc. All the metals and non-metals, synthetic and natural materials, acids and bases are the examples of matter. Water we drink, food we eat, air we breathe, clothes and various things that we use in our daily life are the examples of matter. Let us know more about the concept of matter scientifically. Matter. In a simple way, anything in this world that occupies space and has mass is considered as matter. Everything in our world is made up of matter. The scientists work on stuff. Even the air around us is matter, although we cannot see it. All the things around us which exist in a variety of shapes, sizes and textures is matter. There are three states of matter called solids, liquids and gases. Matter can be changed from one state to another, like a solid to a liquid or a liquid to a gas. Let us learn more about the states of matter, taking water as an example. States of matter. Water can be found in all three states. Because of this, we can say that solids, liquids, and gases are three different states of matter. Click each image to learn more. Now, let us perform an activity to identify the shape and know the volume of liquids. Click each tab to know more. Collect different containers of various shapes like beaker, conical flask, and cylindrical jar. Take some water in a glass. Pour the same amount of water in each container. Mark the level of water and observe the shapes. Repeat the same process with milk and oil. Observe the shapes. In this activity, we observe that liquids take different shapes based on the container, whereas the volume remains the same. Finally, we learn that liquids have no fixed shape but have a fixed volume, and also liquids can flow easily from one container to another container. So liquids are also called fluids. Finally, we learn that liquids have no fixed shape but have a fixed volume, and also liquids can flow easily from one container to another container. So liquids are also called fluids. Let us know about shape and volume of gases. For example, we know that compressed natural gas, or CNG, is a natural gas under pressure which remains clear, odorless, and non-corrosive. CNG comes into the filling station via the natural gas pipeline. The station has a compressor unit that compresses the gas, where it is stored in a high-pressure tank for further use. It is passed from the tank to a CNG-equipped vehicle. Vehicles can use natural gas as either a liquid or a gas. In vehicles, CNG is stored in thick-walled steel, aluminum, or composite tanks built to last more than 20 years. From these observations in daily life, we find that CNG and all other gases neither have a fixed shape nor volume. Now, let us perform an activity to understand the compressibility of different materials. Click each tab to know more. Take a 100 ml syringe. Draw the piston to suck in air. Put your finger on the nozzle. Now press the piston. Observe the depth to which piston moves into the syringe. Repeat the same procedure with water and sand. Similarly, observe the depth to which piston moves into the syringe. From the above observations, we find that gases are highly compressible as compared to liquids and solids. We learn that mostly gases are used for cooking, LPG, and in many automobiles. In all these purposes, large volume of gas is compressed into cylinders of small volume to make them portable. Now, let us perform an activity to observe the diffusion of gases. Click each tab to know more. Take some incense sticks and smell their fragrance. Place them in any corner of the room. Light the incense sticks. Try to smell their fragrance from a distance. In this activity, we observe that when we light the incense sticks, the scent in the vapor form and smoke mixes with the air and moves across the room to reach our nose. Finally, we learned that the movement of air, vapors of scent, and smoke is known as diffusion. In this case, smoke, vapor of scent, and air are highly mobile and are in the form of gases. Let us perform an activity to observe the diffusion of particles of liquids. Click each tab to know more. Take 2 beakers, fill them with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Take a dropper. Now add a drop of potassium permanganate solution slowly along the side of the other beaker. Observe the changes. In this activity, we observe that the particles of potassium permanganate and water spread and mix up with each other on their own. Finally, we learned that the particles of potassium permanganate and water move. Therefore, we can conclude that liquids also diffuse with each other like gases. Let us know about the diffusion of solids, liquids, and gases. We know that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. Carbon dioxide diffuses from blood into lungs. Solids, liquids, and gases diffuse into liquids, and rate of diffusion of gases is higher than that of liquids or solids. Let us do a lab activity to observe the speed of diffusion of 2 gases. Click each tab to know more. The aim of this activity is to observe the speed of diffusion of 2 gases. The materials used in this lab activity are glass tube, rubber bung, ammonium solution, hydrochloric acid, pieces of cotton. Take 2 pieces of cotton wool. Soak 1 cotton piece in ammonia solution and the other piece in hydrochloric acid. Take a narrow glass tube. Insert both cotton pieces separately at the 2 ends of the glass tube. Now close the both ends with rubber bung. Observe the changes. In this activity, we observe the formation of a white ring from the least distance of piece of cotton with HCl solution. Because the hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Thus, we learned that the both gases react together to form a white substance called ammonium chloride. Therefore, we can conclude that HCl is more dense than NH3 because NH3 travels a farther distance than the HCl in the same period of time. Can matter change its state? We all know from our observation that water exists in the 3 states of matter: solids as ice, liquids as the water, and gases as water vapor. We must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid in state, but if the weather is too cold, it becomes solid. Similarly, camphor is a solid, but if we leave it in the open air for some time, it changes to gas. Solids, liquids, and gases are the different states of matter, but the properties of matter are different in different states. This is because all matter is made up of very tiny particles. Let us do some activities to know about these particles and their arrangement in their various forms. Here, let us perform an activity to know how small are the particles of a matter are. Click each tab to know more. Take a beaker. Fill it with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Now, take out approximately 10 ml of this solution and add it to 90 ml of clear water in another beaker. Once again, take out 10 ml of this solution and add to another 90 ml of clear water. Carry out this process 3 or 4 times and observe changes in the color of the solution. We observe that the solution remains colored even when highly diluted, but the color of the solutions decreases with dilution. Finally, we conclude that there must be several tiny particles in just one crystal of potassium permanganate which get uniformly distributed in water to change its color. Now, let us perform an activity to understand the force of attraction between the particles of the matter. Click each tab to know more. Take a beaker. Fill it with water. Mark the water level. Add some salt to the water. Stir it thoroughly with a spoon. Observe the changes. Once again, add some more salt to the water and stir it. Now, observe the changes. Here, we find the changes in the levels of water. Open a water tap. Allow the water to reach the ground. Now try to break the stream of water with finger. Release the finger after few minutes. Observe the changes. Here, we observe that the water flows with more velocity than its normal velocity for few seconds after the finger is released. Later on, the water reaches its normal velocity. Similarly, we observe that the forces of attraction between particles are the maximum in solids, intermediate in liquids, and minimum in gases. Finally, we learn that both solid and liquid particles have some space between them. The solid particles enter in the space between the liquid particles when solids dissolve in liquids. We also learn that the particles of the matter have forces acting between them that keeps the particles together. It is also clear that this force is not equally strong in all the forms of matter. The force between particles of matter is called as cohesive force. Diffusion of matter. The intermixing of particles of two or more different substances on their own is called diffusion. In the incense stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The rate of diffusion of gases is very high because the particles of gases travel with high speed. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than solids. There are two reasons for the higher rate of diffusion of gases. One is due to the higher speed of gas particles and another due to the greater space between them. Similarly, the liquids have greater diffusion rate than solids because particles in liquids move freely and have greater space between them when compared to particles of solids. The screen shows the difference in arrangement of particles in solids, liquids, and gases. The diffusion of solid into another solid substance is negligible due to the immobility of particles in solids. The diffusion of a liquid into another liquid and that of a solid into a liquid is much slower than the diffusion of gas into another gas. The following table shows the comparison of the properties of solids, liquids and gases.
Knowledge check. Attempt the
Here, let us perform an activity to know the effect of temperature on change of state. Click each tab to know more. Take a beaker filled with small ice cubes. Insert a thermometer into the cubes. Observe the thermometer reading. Now put the beaker with ice cubes on a burner with help of tripod stand and start heating the beaker. Then the ice cubes start melting. Observe the changes in the thermometer reading for every 1 minute until all the ice melts. In this activity, we observe that the temperature of the mixture of solid ice and liquid water does not change for some time. It changes only when it reaches specific temperature. The temperature starts changing only when ice completely melts. Finally, we learned that at a certain temperature, the solid melts and changes into liquid. The temperature at which a solid melts to become a liquid is called melting point. The process of changing a solid to liquid is known as fusion. Here, let us perform an activity to know the effect of temperature on change of state. Click each tab to know more. Take a beaker and pour some water in it. Place it on the burner with the help of tripod stand. Measure the temperature of water with the help of thermometer and note down the readings for every 2 minutes. Observe that the temperature of the water increases continuously till it reaches 100 degrees Celsius. In this activity, we observe that the water boils to steam when the temperature reaches 100 degrees centigrade. This shows that the particles in water vapor at 100 degrees centigrade have more energy than the particles in liquid water at the same temperature. Finally, we learned that at a certain temperature, the particles have enough energy to become free from the forces of attraction among the particles and the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling point of water is 100 degrees centigrade. Let us know some important definitions. The following tabs give the information about the latent heat of fusion, latent heat of vaporization, and anomalous expansion of water. Click each tab to know more. Heat required to convert 1 gram of solid, that is ice, completely into liquid at a constant temperature is called latent heat of fusion. Consider a solid of mass, that is m, which converts from the solid phase to liquid phase when heat, that is Q, is supplied to it. The heat required to convert gram of solid into liquid is Q by m. Latent heat of fusion L is equal to Q by m. The value of latent heat of fusion of ice is 80 calorie per gram. Heat required to change 1 gram of liquid, that is water, to gas at constant temperature is called latent heat of vaporization. Assume a liquid of mass as m requires heat Q calories to convert its state phase of liquid to phase of gas. Then latent heat of vaporization is given by the expression Q by m and is denoted as L. SI unit and CGS unit of latent heat of vaporization is Joule per kilogram and calorie per gram respectively. A liquid usually expands when it is heated, but water behaves differently. Between 0 degrees centigrade to 4 degrees centigrade, its volume shrinks. Same amount of water in solid ice occupies more volume than liquid water. We say that water expands, increases in volume on freezing from 4 degrees centigrade to 0 degrees centigrade. This is an anomalous expansion of water. The density of ice is less than that of water, and this explains why ice floats on water. A liquid usually expands when it is heated, but water behaves differently. Between 0 degrees centigrade to 4 degrees centigrade, its volume shrinks. Same amount of water in solid ice occupies more volume than liquid water. We say that water expands, increases in volume on freezing from 4 degrees centigrade to 0 degrees centigrade. This is an anomalous expansion of water. The density of ice is less than that of water, and this explains why ice floats on water. Effects of change of pressure on matter. We know that water exists in 3 different states, namely solid, liquid, and gas, which are otherwise known as ice, water, and vapor. Top of high mountains and Arctic and Antarctic oceans have water in the form of ice, that is, snow. Oceans, rivers, and lakes have water in the liquid form. The vapor form of water is present in the atmosphere. Steam is observed when water is boiled. We also make ice using the special section given in the refrigerators called freezer. It is important to note that the 3 states of water are interchangeable. When water is boiled, steam is observed. On the other hand, when steam, that is gas, is cooled, water, that is liquid, is obtained. On heating, ice, that is solid, changes into water, that is liquid. If water, that is liquid, is cooled below 0 degrees centigrade, we get ice, that is solid. Similarly, solid carbon dioxide converts directly into gaseous state when the pressure is decreased to 1 atmosphere. Due to this reason, solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. Here, let us perform an activity to know the effect of wind speed on evaporation. Click each tab to know more. Take a small amount of spirit in a cup. Pour a few drops on your palm. Observe the changes. Once again, take a few drops of spirit, say 1 ml, and pour the drops into 2 Petri dishes individually. Generally, the Petri dishes are shallow glass or plastic cylindrical lidded dishes used in the laboratory. Place both the dishes under a ceiling fan and switch it on. Close the lid of one dish. After 5 minutes, check the quantity of spirit in both the dishes. In this activity, we observe that the spirit disappears in the dish kept under the ceiling fan. At the same time, some quantity of spirit can be found in the dish which is closed. Finally, we learned that evaporation is a surface phenomena. During evaporation process, the particles escape from the surface of liquid. The increase in the surface area provides more scope for particles to escape from the surface, and this increases the rate of evaporation. The phenomena of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Humidity is another factor that affects evaporation. The amount of water present in air is called humidity. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water vapor is high in air, the rate of evaporation will decrease. So clothes dry slowly during rainy season but fast on a sunny and windy day. Because of increase in wind speed, water vapor particles move away with the wind, decreasing the amount of water vapor in the surroundings. When we work, the body produces heat. This increases the temperature of the skin. As a result, water presents in the sweat glands. The particles of liquid absorbs energy required for evaporation from our body and escape to the surroundings. This makes us to feel cool. Follow-up work. Prepare a model to demonstrate movement of particles in solids, liquids and gases. Suggest an activity which provides the evidence for the motion of particles, attraction between particles and interparticle space. You have successfully completed the chapter Matter Around Us.